welcome back. Today we're going to be talking about triangle midsegments. And as you can see here, I've got this triangle. And what I've done is I have already drawn the midpoints. And so D, E, and F are the midpoints. And what you can see is I have the midsegment triangle here because it's the triangle formed by the midsegments. And what I've done over here is I have done a little calculation where I've measured each of these side lengths and the midsegments. So for example, if I look at DE and BC, they are related because if I'm doing the midsegment of ABC and I drew in DE, okay, so BC here is 10.16 is what it is right now, is going to be related to DE because it's the midsegment that goes with that base. All right, so the midsegment and the base are what we are traditionally going to pair up. And so what you can see here is I'm going to do a little bit of a measurement and I'm going to calculate something here. And what I'm going to set up is I'm going to set up a ratio of the midsegment, so DE, let me just, the measure of DE, and I'm going to divide that by the measurement of BC. Okay? So that's my first measurement. You'll notice when I do that problem, DE over BC is 0.5, so it's a half. So DE is half of BC. Well, I'm going to set up another calculation here. And what I'm going to do is I'm going to measure the other midsegment. So if I look at C right now, EF and AB are going to be my targets. So I'm going to pick EF and I'm going to divide that by AB. All right, so there's my second measurement. Notice, same ratio. Haven't moved this triangle yet. Okay, haven't moved anything around yet. My last one is going to be DF and AC. I'll set up that last calculation. So DF and divided by CA or AC. Now, all of those are a half right now. So here's what I'm going to do. I'm going to do a little bit of movement. Hopefully that's what you did in your exploration, and I'm going to see something, see if some things change. Okay? All right, make a little obtuse triangle here. Maybe I'll make kind of a right triangle look in here. What do you notice? All the measurements are moving. What's not moving? Okay, what's not moving here? I'll pick A for a second. Move that one around. Those ratios are not moving. Now that's what I'm talking about when we start to talk about the mid-segment theorem. So the mid-segment theorem is based on this concept of having a triangle with mid-segments in the middle and a mid-segment triangle. And we notice about the mid-segments, they form a ratio of a half with what? Let's look. Triangle mid-segment theorem. The midsegment of a triangle is parallel to the sides of the triangle and it's half the length of that side. So I'm going to start at the top. And I've got segment DF. Let me grab a. So DF. Okay. Segment DF is parallel to AC. How do I know? Well, this triangle's already been marked up. I know it because of this. DF over AC is equal to 1/2. How do I know? Well, this measurement here is a half. You saw it in that visual proof that we just did. So how do I know that they're parallel? Well, if I notice when I draw this mid-segment triangle in, the distance between D and A is 1 tick mark, but also E and F is 1 tick mark because EF is half as long as this side. So you start to see how everything is related. Let's do another triangle. FE over BA is equal to 1/2. So the midsegment is half as long as the side it is opposite of. DE over BC is also equal to 1/2. How does this translate into problems? Well, we know these parallel lines, so I can also say that DF is parallel to AC. And I could also say that FE is parallel to BA. And DE is parallel to BC. Now certain relationships exist. Let me scroll up a little bit here. I have a mid-segment triangle here. I know that because each of the sides is divided in half. 1 tick mark each, 2 tick marks each, 3 tick marks each. So if I want to find BD, I know that this is a mid-segment, and so I'm going to look to this bottom because I know that BD is 1/2 of AE, and then I'm going to substitute in. So BD is equal to 1/2 of 17, so it's going to be 8.5. That's all there is to it. When it comes to measurements of angles, it's a little bit trickier. It's going to combine some things that we've talked about with parallel lines. So C, B, D. Remembering, of course, that these lines here are parallel, right? Okay, and so they're cut by these transversals that cut through here. And so if this angle is 26, what I'm really dealing with is pairs of parallel lines. So these are parallel, these are parallel, and so these angles are actually alternate interior angles. And so this is going to be 26 degrees as well because they're alternate interior angles. AC. AC is the long length. Well, you'll see that it's mid-segment. FD is 1/2 of that base of a triangle, so 1/2 of AC. So let's see. 6.2 is equal to 1/2 of AC, so I have to multiply both sides by 2. So 12.4 is equal to AC. That's all there is to it, guys. The mid-segment theorem, they are half as long and parallel to those bases. So why don't you try this one? Go ahead and see what you can do with it, and we'll see you next time.